Right, I've got the International A-Level P4 October 2021, question 10, the last one on the paper, proof question, proof by contradiction. Part A, we got proof that somebody is trying to show that if n cubed is even, then n must have been even. And then the part B, proof by contradiction that the cube root of 2 is irrational. There's that very famous proof that the square root of 2 is irrational, which you're supposed to know. Sort of a variation on that, but it uses the same technique. So the first part, we're going to prove by contradiction. And there's a missing line here, so we assume the opposite. So there is a number where if n cubed is even but n is odd, so we're trying to prove the opposite of that. So if n is odd, then we can write it like this: 2 lots of p plus 1. And if we cube that and expand it out, we get this. The missing line, well, we need to write this as an odd number. So it's like 2 lots of this. So this is an even number because it's 2 lots of something, then plus 1, which is odd, and that's sort of the missing line. And then that does contradict our initial assumption because we've got an odd number where we thought it was going to be even. So that's 1 mark. I'll show you the mark scheme. You could have written even plus even plus even plus 1 is an odd number. That would allow that. But you need to have that word odd in there somewhere. You could even take the P, a P out of there and write it like that. Then the second part, it's proved by contradiction that the cube root of 2 is irrational. We're going to use what we got in the first part. So we assume that the cube root of 2 is rational to start off with. So we can write it as a fraction using whole numbers, P over Q, I'm going to call it. So where P and Q are integers, and crucially, where P and Q has been cancelled down into its simplest form. And then, right, so I can cube this. So I'll get 2 is P cubed over Q cubed, rearrange it, stick the Q cubed up there with the 2. And that tells me that P cubed is an even number because it's 2 times Q cubed. And then from the first part, that implies that P must have been an even number. I can't cube an odd number and get an even number. So P is an even number, which means I can write it as 2 times R, 2 times something, and then I'm going to put this into here for P. So I have 2Q cubed is 2R all cubed, which is 8R cubed. Divided by 2, I'll get Q cubed is 4R cubed, and this is an even number as well. It's 4 times it, so it's definitely 2 times it. So Q cubed is even, implying that Q is even, which we got from the first part. So that contradicts our initial assumption that P over Q is in its simplest form. We can divide them both by 2 because they're both even. So the cube root of 2 is irrational.